Hi and welcome to Calculus 30 with Miss Verity. Today we're going to be looking at the derivatives of sine and cosine functions. So to start off with some things that you should know, we're going to look at those key pieces of information you would have learned in Pre-Calc 30. So to start off with, we've got our all favorite special triangles. So this is 30, 60. We've also got our 1 root of 2, and that's our 45-degree triangle. Within that, we also have our quadrants, where this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Remembering that our points also come as cos and sine. That's our x, that's our y, which that in turn comes from, we also know SOHCAHTOA. Other important things is if we want to remember what our radian values are. Well, radians, anything that is a pi over 6 is a 30-degree reference angle. Anything that's pi over 3 is a 60-degree reference angle, and anything pi over 4 is a 45-degree reference angle. The pi over 2s, that is our quadrantal values. That's these points. I'm going to let you peruse through that for a minute. I will post an answer key on the Google Classroom, but just some things that you should practice. As well as here is our proof for the derivative of a sine function. I'm not going to go through it in details, but just know the derivative of sine is cosine. So using that, if we have y is equal to the sine of u, then dy dx is the cosine of u times du dx. Basically what that means is it's the derivative. It's kind of like the chain rule, or like with our natural logarithms and all those ones that we looked at. It's basically the sine of the stuff times the derivative of, it'll be the cosine of the stuff times the derivative of the stuff, if we want to use stuff as our technical term. Okay, so find the derivative of each. So y prime, so remember 2x is kind of like our u in this case. So the derivative of sine is cosine of the stuff times the derivative of the stuff. So this would be 2 cos 2x. Our next one, did you recognize that this was a product rule? So when we treat it like that, we've got y prime is equal to the derivative of the first, which is 2, times the second, plus the derivative of the second, and the derivative of x is 1, times the first. You probably want to take out some common factors. We can take out a 2, and we are left with sine of x plus x cos of x. I'm going to skip over C. We're going to go to D. So derivative of sine is cosine. So cosine of the stuff times the derivative of the stuff. Well, derivative of e to the x is e to the x. So simplified, we're going to have e to the x times cos of e to the x. For E, so this is a chain rule. So this is logarithm of the stuff. So when we take the derivative of the logarithm, it's 1 over the stuff times the derivative of the stuff. Nope. 1 over the stuff that times. Okay, wow. Let's back up. Okay, so now we're going to take the derivative of the sine of 3x. Well, the derivative of sine of 3x is cos of 3x times the derivative of the stuff. So if we were to rearrange this, we are going to get 3 times, we could also have the 3 in our numerator, 3 cos of 3x over sine of 3x. And hopefully you remember that cosine over sine is cotangent. So 3 cotangent 3x. All right, on to our next one. So this one as well, remember that when we have sine squared 3x, that's really the same as saying sine of 3x. squared. So again, we've got a chain rule. With our chain rule, we are going to have, so 2 times the stuff, decrease our power, so be to the power of 1, times the derivative of the stuff. So the derivative of sine is cosine times the derivative of the inside stuff, which is 3. And so now when we simplify, we're going to get 6 sine 3x cos 3x. Excellent. Next, we've got the proof of cos of x, or the derivative of that. I mean, if you want, take a perusal, read through it. Cos of x, well, the derivative of that happens to be negative sine of x. So watch that negative. Okay, determine the derivative of each. So the derivative of cos is negative sine of the stuff times the derivative of the stuff. Negative 2 sine 2x. Our next one, again, we've got a product rule. So derivative of 2x is 2 times the second plus derivative of the second. So derivative of cos of x is negative sine of x times the first. So take out a common factor of 2. We are left with cos of x minus x sine x. Our next one, again, if you don't like the look, you can rearrange it. I'm going to rearrange it to be 10 cos of 5x squared. So derivative, we're going to multiply our power with our coefficient out front. We're going to get 20 cos of 5x. We're going to decrease our power by 1, so that's down to a 1, times the derivative of the inside. So derivative of cos is negative sine times the derivative of the stuff. And so simplified, we are going to end up with negative 100 cos of 5x sine of 5x. If we look at D, so our derivative of cos is negative sine times the derivative of the stuff. So this is going to be negative 2e to the x sine of 2e to the x. For E, personally, I am usually not a fan of the quotient rule, but in this case, just because we're starting to deal with more complex stuff, you know what, I may dabble in it. So if you remember, which I sometimes hardly do, our derivative is going to be the derivative of the top, so 6x times the bottom, 2 cos of x, minus the derivative of the bottom, so negative 2 sine of x times the top, all over our denominator squared. So if we simplify this, we're going to get 12x cos of x plus 6x squared sine of x all over. Remember, this squared is going to apply to both terms. So we're going to end up with 4 cos squared of x. Remember that cos of x squared is the same as cos squared of x. And if we want to simplify, which we sure do, when we are dividing things, we are technically dividing both terms by the denominator. So I'm just going to rearrange it. 12x cos of x divided by 4 cos squared of x plus 6x squared sine of x over 4 cos squared of x. Ooh, I'm going to run out of room. All right, so to simplify, 12 divided by 4 is 3 cos divided by cos squared is 1 cos in the denominator. If you remember, cosine in the denominator, that is the same as secant. 3x secant x plus 6 over 4, that's going to reduce to be 3 over 2. If we've got, so this, if we wanted to take it, we'd have sine of x over cos of x, cos of x. Well, sine of x over cos of x, that is tangent, and that also leaves us with a 1 over cos of x. So 3 over 2 x squared. So sine over cos, that is tangent, and 1 over cos is secant. And we're going to take out a common denominator, so we are going to take out 3 over 2x secant x. That leaves us with 2 plus x tan x. And I think that's where we're going to leave it for today.